So welcome to the review. These are the videos for Probability and Set Theory Lesson 4. Once again, for Shaughnessy's class, please make sure that you're showing up to class. Otherwise, though, let's keep going. Now this one is actually harkening back to Perms and Com. Okay, we've got Perms and Com's ideas. Because once you understand probability, that's favorable over possible, which is kind of what we were talking about yesterday. Once you get that, Perms and Coms just makes it harder to figure out the favorable or figure out the possible, but it's still the same idea. So if I look at this one, and I'm apologizing because I'm just going to refocus this now that I'm finished bumping it. Probability with Perms and Coms. Permutations. Keeping in mind it's the number of arrangements of n objects placed r at a time, so n objects placed r at a time, okay, in the specified order. So you're arranging them, you're putting them in positions, keeping in mind in permutations order matters. In combinations, the number of groups of r objects selected from a group of n objects. So you're just making a group. The analogy that I used was stew in class. The idea here is that it doesn't matter what order they're chosen in, it's essentially all one and the same thing. So you've got NPR for that one, you've got NCR for that one, keeping in mind that for permutations the fundamental counting principle also exists. It is very similar. You've got that sort of idea. Now the formulas themselves are on the formula sheet, okay? You have them, and we used them in the unit. Right now I'm not worried about them because I'm not going to be touching on them, but the idea there is what's going on. Now, going down here, in some probability problems, we need to use our Perms and Coms knowledge in order to determine the value of the number of favorable outcomes, or the number of possible outcomes. Sometimes you have to do it in one, sometimes you have to do it in both. Now, in this one here, this is the question we kind of did yesterday. A toddler is arranging 5 DVDs, including The Incredibles. What is the probability that he arranges them in alphabetical order? So the probability that it's alphabetical, I'm just going to write P at A, okay? The probability that it's alphabetical. Well, alphabetical order. You have to ask yourself, it's favorable over possible. So that much is set. There's one favorable alphabetical order. For the possible orders, you have to ask yourself, how many ways can this be arranged, or how many different arrangements are possible? Now, as soon as I say arrangement, I know I'm talking permutation, okay? Because I'm putting them in set positions, order matters. So I know this is going to be a permutation. I've got 5 to arrange, and I'm arranging all 5. That becomes a permutation, so I get 5 pick 5. This is the one we did yesterday. So 1 over 120, and that is my probability. There's a 1 in 120 chance that he does that. Now I can make this much more complicated just by changing what's going on with the Perms and Coms. He arranges the DVDs so that The Incredibles is in the middle, okay? So I've got The Incredibles in the middle. I'm just going to write Inc, okay? The probability that The Incredibles are in the middle is favorable over possible. Now, once we get this done, I already know possible. Possible's 5 pick 5. 5 pick 5 or 120. The possible always stays. It's always the same. Okay, as long as the context is the same, it's always the same. Now I've got to think about putting The Incredibles in the middle. So now I'm thinking back to Perms and Coms. So on my scrap paper or off to the side, I'm thinking, well, if I want The Incredibles in the middle, I've got 5 blanks, and there's one choice for the middle video, The Incredibles. After that, once I've placed The Incredibles, there's 4, 3, 2, and 1 for the remaining spots. So I could say it's 4 factorial, or I could say it's 4 pick 4. However you want to do it is fine, but that is my favorable, because that is the number of situations that have The Incredibles in the middle. Now 4 pick 4, or 4 factorial, I'm just going to put 4 factorial. 4 factorial is what's there. So I have to figure out 4 factorial. Now 4 factorial is 4 times 3, which is 12, times 2 is 24. So I get 24 over 120. Now technically that's correct. It's not reduced, and I will in a minute. But nonetheless, that's what's going on. I'm using my Perms and Coms knowledge to figure out the favorable and or the possible separately. Keep in mind for this one here, I didn't use Perms and Coms for favorable. I just used logic. Here, I used perms and cons for possible, but I didn't redo it. I just said, well, I'm still talking the same thing, so I just carried it over. So I used logic to get that 120. It was the perms and cons that I needed for the 4 factorial. Now when I reduce that, I'm just going to keep going, and that's going to be 12 over 60. I'm dividing by 2, which is going to be 2 over 10, which is going to be 1 over 5. Okay? So 1/5 is the probability of that. There's a 1 in 5 chance that he puts the Incredibles in the middle. Okay? So 1 in 5 chance. All that's happening here, all that I'm doing here is I'm taking the perms and cons stuff that we did before, and I'm making them so that it's just a few questions in one. And I want probability. This one here, e.g., a group of 8 men, 7 women, including David, nominated to serve on a 4-person committee. The committee is randomly selected. Now that's the key thing, randomly selected. Because if it's not randomly selected, then you can make anything happen you want. So it's randomly selected. What is the probability that the committee is all men? So the probability that it's all men is going to be the number of favorable. Now that in this case is going to be the number of committees that's all men over the number of possible, the number of committees in total. Now keeping in mind committee, it doesn't matter the order, this is a combination. So I usually go and try to figure out my possibles first. Now in possibles, how many 4-person committees can I make? Well, there's 15 in total, and I've got to choose 4 of them. So I get 15, choose 4. Okay? And so I'm going to figure that out in a second. That's my possible. My favorable is going to be 4 men. So I think, well, how many ways can I get those men? Well, that's 8, choose 4. Okay? So I end up with that. There are 8 ways that I can get 4 men, 15 committees in total. I'm wheeling away because I realized I don't have my calculator handy. All you do now, though, is you figure out these 2 numbers. 8, choose 4. And I'm in my calculator, same as I did before. 8, choose 4 is going to be 70. 15, choose 4 is going to be 1,365. Now I would reduce that fraction. So 70 divided by 1,365. And my calculator can do this for me, is 2 out of 39. And there you go. Okay? So that's this probability. The probability that this randomly selected committee is all men is 2 out of 39. Now I can just take this context and do more. David will be on the committee. So the probability that David is there. Okay? It's favorable over possible still. Within the same context, the possible is the same, so 1,365. I calculated it before, I'm keeping going with it. I'm trying to think now David being on the committee. Well, if David is there, I've got David plus 3 other people. Now, if David is included in these 15 people, there are 14 left, and I got to choose 3 of those. So I get 1 times 14, choose 3. And if I figure that out, I get 364 over my 1365 because the possible stays the same. And if I do that as a fraction and try to reduce it, I'm going to get that reduces to 4/15 and I'm done. Okay? So on and so forth. So there's a 4 in 15 chance that this happens. And all I do is keep going. What's the probability that David will be on this committee with exactly 3 women? So the probability of David and 3 women, okay, it's going to be favorable over possible. Okay, the possible is still 1,365. Okay, my David and 3 women, I've got David and I've got 3 women. Now there are 7 women. If you go back to the question, there's 7 women and I've got to choose 3 of them. And so I get 1 times 7, choose 3 is my favorable. My possible is still the same thing. So if I do 1 times 7, choose 3, I get 35. So it's 35 over 1365. And I reduce that. And and it's going to be 1 in 39. So there's a 1 in 39 chance that he's on the committee with 3 women. Okay? And so on and so forth. Now you could do the same thing with men. I'm just kind of going with this idea. So I've got David with exactly 2 women. So I've got David with 2 women. So the probability of David and 2 women, but it's a 4-person committee. So don't forget, just because it's not mentioned, that our last person must also be a man. So I've got favorable over possible. The possible is still 1,365. I've got David, 2 women, which is going to be 7, choose 2, and I've got 7 other men. David is one of the men. There were 8 men. David's gone. 7 men left, and I need one of those. 7, choose 1. And if I work that out, I've got 7, choose 2 times 7, choose 1, times 1, which I don't need to do. And if I figure that out, I'm going to get 147. So there are 147 committees out of the 1,365. And I see if that reduces. I don't know if it does. Oh, it does. Okay, it's 7 out of 65. So there's a 7 in 65 chance that that works. Okay? But all I'm doing is I'm using my perms and coms because of the context of the question. This one here is talking about committees. Committee order doesn't matter, so I'm using combinations. The one with the DVDs that we just did before was arranging, order mattered, that sort of thing. So in this one here, in E, I suddenly forget about David for a second. There are more women than men. So the probability that there's more women, okay, would be the probability that there's 3 women and 1 man, or the probability that there's 4 women and no man. Okay? So those are my situations. So I've got to take those. The 3 women and 1 man. Well, it's favorable over possible. My possible still 1365. Ditto over here. My possible still 1365. Okay? 3 women and 1 man. Okay? That's 7 choose 3 for the 3 women, and 8 choose 1 for the 1 man. Or I've got 7 choose 4 for the 4 women. So I've got these 2 fractions to figure out. And so 7 choose 3 is that, times 8 choose 1. It's 280 over 1365. Plus, and in this one here, it's 7 choose 4 is 35 over 1365. Add them together, you keep the denominators the same. Remember, we've been doing fractions. So I get 280 plus 35 is 315 over 1365. And 315 divided by 1365, I'm going to see if it reduces. It reduces to 3/13. Okay? So on and so forth. Now all I'm doing is I'm using perms and coms. There's a variety of ways to set up your work for that last one, but nonetheless that's there. Now, the probability that David will not be on the committee. The probability that David will be on the committee is 4/15. So I know that. That's from B. The probability that David is on the committee is 4/15. Okay, there are lots of ways to do this. Here's probably the easiest. If David's not on the committee, that's the complement of David being on the committee. So the complement is 1 minus the probability that he was, 4/15. 1 minus that is going to be 11/15. That's probably the easiest way to do this question. You could go through and calculate something over 1365. Either way, it would end up reducing to 11 over 15. Okay? So I like this whole idea. As soon as you get to probability, you have a little bit more flexibility. Okay? Going through with this idea, this is probability with perms and coms. And that's all that we're talking about. Okay? Your favor, or your possible, is always the same, as long as the context is the same. So I'm talking about a 4-person committee. Okay? If my context is the same with this 4-person committee, my possible is going to be 1365. The thing that's changing is my favorable. This is difficult But this is just the idea. The reason it's difficult is because perms and cons is difficult to begin with. So once you have perms and cons and you've got to do 3 or 4 questions and put it as a fraction, it makes it even more complicated. But this is the idea. You've just got to figure out favorable and possible. Okay? If you know the favorable, you just say it. That was the alphabetical one. It was 1. Sometimes it's that simple. Sometimes you have to do perms and cons to get it, which is what's happening here in this committee one. Otherwise, that's it. It's going to be work period for the rest of class. Hopefully that makes sense. If you have any questions, come see me. Thanks.